In this video lecture, I'll be explaining to you the quicksort algorithm. We'll see what is quicksort, how it works, and we'll also learn the algorithm with the help of an example. With that said, hey guys, I'm Amir Salam, and on this particular channel, I upload content related to coding, technology, and self-development. If that is something within your interest, then consider subscribing to my channel. With that said, let us not waste any more time and let's jump right into the topic. First of all, what is quicksort? Well, straightforward, it is the most efficient sorting algorithm which follows divide and conquer approach. Now, one key characteristics which sets quicksort apart from all other sorting algorithm is that it is an in-place sorting algorithm. Now, what is an in-place sorting algorithm? What happens with quicksort is that it doesn't create multiple copies of the unsorted array. Let us take an example of merge sort. What merge sort does is it creates multiple copies of the unsorted array and then sorts them back. Now, the big advantage with quicksort is that without creating multiple copies of the same array, we save a lot of memory space. Now, this is one advantage of quicksort, that is, it is an in-place sorting algorithm. With that, quicksort has time complexity of big O of n log n, which makes it faster compared to all other sorting algorithm. Hence, quicksort is always preferred over other algorithms. Now, this was a very basic definition of the quicksort algorithm. Let us see how quicksort algorithm actually works. Now, the key component in quicksort algorithm is the pivot element. First, we have to choose the pivot element. Based on the standards, following the culture, the last element of the array is always chosen to be the pivot element. Once we choose the pivot element, we have to partition the array in such a way that the partitioned subarray towards the left side of the pivot element will hold elements which are lesser than the pivot element, and the other subarray which falls towards the right hand side of the pivot element will hold the elements which are greater than the pivot element. For example, if I take sample of an array, suppose 2, 7, 3 and 8 and 4, okay, and if I choose the element 4, okay, the last element, to be the pivot element, it has to be arranged in such a way that 4 falls right in the center and all the elements which are lesser than 4, that is 2 and 3, will fall towards its left side, and the elements which are greater than 4, that is 7 and 8, will fall towards its right side. So this is one subarray and this is one subarray. Then we'll again partition this array, we'll again partition this array, and it goes on until we obtain the fully sorted array. So as I've explained it, partition the array into subarrays where elements smaller than the pivot element will fall towards its left hand side, and the elements which are greater than the pivot element will fall towards its right hand side. Then this process occurs recursively and we repeat this until we obtain a fully sorted array. So this is basically how the quicksort algorithm works. Now let me explain this algorithm with the help of an example. Let me take an array of maybe size 7. Okay, so the array I'll be taking is 2, 6, 8 and 0, 1, 3 and 7. So once I call the quicksort function, right, quicksort, and if I pass this array 2, 6, 8, 0, 1, 3 and 7 as an argument, what happens is, first of all, this element, the last element 7, will be chosen to be the pivot element. I'll choose this element as a pivot element. Now there are two conditions. The first condition is that if element at jth position is lesser than the pivot element, what we have to do is, first we have to increment I, then we have to swap array of, or the element at ith position and element at jth position, then we have to increment j. Okay, if this condition is false, then we just have to increment the variable or the value of j. So this is one condition. Okay, now the second condition is, if j is equals to pivot element, okay, or else if we reach the last or the end of the array, what happens is we have to increment I and we have to swap the element at I and element at j. Now you might feel a little bit confused after going through these two conditions, don't worry. Using this example, I'll explain this to you. Now let us start from this very first condition. First, if array of j. Now what is j and I? Let me tell you, these two are indices. We use I will be pointing towards one step before the start of an array. So I will be pointing here, whereas j will be pointing exactly at the start of an array. So what is element of j? That is 2. Is 2 lesser than 7? So let me see. Is array of j, which is 2, is it lesser than the pivot element 7? The condition is true. So first is I have to increment I. Okay, I will be incremented. So I will now be pointing to element 2. Second is I have to swap element of I, which is 2, with element of j, which is 2 once again. So if I swap this element with the same element, nothing changes. So now next is I have to increment j. So j will be incremented, and now it is pointing to element 6. I'll write it down clearly. So index I is pointing here, j is pointing there. Now we are done with this. Again, we'll check if element at j, that is element at j, that is 6, is 6 lesser than the pivot element 7? The condition is true. Once again, I will be incremented. The first step itself is I should be incremented. Next, swap array of I, the element at I, that is 6, with element at j, that is 6. So swapping 6 with 6 doesn't make any change. Next is we have to increment j. J will be incremented. If I write it down clearly, this is how it's gonna look. I is pointing to the value 6 and j is pointing to value 8. Now again we'll check, is 8, okay, is 8 lesser than 7? Is 8 lesser than 7? The condition is false. So we'll jump to this part, else part. J is incremented. Now j is incremented to point at the element 0. Here it is pointing. Now once again we'll check if the element at j, which is 0, okay, is 0 lesser than 7, the condition is true. So we'll get into this particular if block. So first I have to increment I will be now incremented from this position to this position. Okay, now I have to swap array of I and array of j. That means I have to swap the element at I and I have to swap element at j. So if I swap 8 and 0, this is how it's gonna look. 0 is gonna come to this place and 8 will go here. Next, the next step is we have to increment j. So j will be incremented to point at the element 1. Okay, so this is how it's gonna look like now. Now once again we'll check, is 1 the element at j, that is 1 lesser than 7? The condition is true. Once again I will be incremented. Okay, once again I will be incremented to point at 8, and we'll be swapping 1 and 8. Okay, we'll be swapping 1 and 8, as that is the second step. 1 and 8 will be swapped. Now the third step is j must be incremented. So once incrementing j will now be pointing to element 3. Okay, I'll erase this. So this is how our array is looking right now. Once again we'll check, is the element at jth position, that is 3, is 3 lesser than 7? The condition is true. So what happens is, once again I value is incremented. I is now pointing to the element 8. Then we have to swap 8 and 3. So after swapping 8 and 3, what happens is 3 goes to this position and 8 is put on to this position. Now the next step is we have to increment j. After incrementing j, we reach to the end of an array. Now we are done with the first condition. Now let us look at this part. If the j, if j is pointing to the pivot element or at the end of the list, what must happen is, first step is we have to increment I will be incremented to point at the element 8, and then we have to swap element at ith position and element at jth position. After swapping 7 and 8, this is what we'll be getting. So 7 will be placed here and 8 will be placed here. Now in the very first pass, as you can see, the pivot element, which was 7, has been placed in its right position. Now how are we supposed to judge if it has been placed in its right position? Well, as we can see, all the elements towards its left hand side are lesser than 7 and all the elements towards its right hand side are greater than 7. Once we are done with this, now this array will be partitioned into one part and this will be partitioned into another part. So again we'll call the function recursively quicksort and we'll be passing this subarray as an argument 2, 6, 0, 1 and 3. Once we pass this particular array, now the element 3, which is the last element, is now the pivot element. Okay, now once again we'll follow this same condition. Let me select this, I'll place it down below. Okay, now this is where I will be pointing and this is where j will be pointing. Let me compare, is the element at jth position, that is 2, lesser than 3? The condition is true, so I will be incremented, then swapping occurs, so no major change, again j will be incremented. So this is how it's gonna look like. Now I'll check, is 6 lesser than 3? The condition is false, so I'll just be incrementing j. Once the j is incremented, I'll again check, is 0 lesser than 3? Is 0 less than 3? The condition is true, hence I value must be incremented, 0 and 6 must be swapped. After swapping, what happens is 0 goes on to here and 6 will be placed here. Okay, the next step is we have to increment j. So once j is incremented, it is placed here. Okay, now once again I'll check, is 1, the element at jth position, 1 lesser than 3? The condition is true, hence what happens is again I value is incremented, again I and jth position are swapped, that is 1 and 6 must be swapped. Once again 1 goes here, 6 will go here, then j must be incremented. Okay, now the second, let us check with the second condition. J has reached the pivot element or the end of the array, so what happens is I must be again incremented and the element at I and element at jth position must be swapped. So 6 and 3 will now be swapped. 3 goes here, 6 goes here. Now as you can see, the element 3, which was the pivot, has obtained its right position. Let us compare. All the elements towards its left hand side are lesser than 3, all the elements towards its right hand side are greater than 3. Now once again this array will be partitioned. Okay, now we'll again recursively call quicksort and we'll pass this array 2, 0, 1. Okay, here what happens is in the array 2, 0, 1, 1 is considered to be the pivot element. Again I will be pointing one step behind the start of an array and j will be pointing exactly at the start of an array. Let us compare, is 2 lesser than 1? The condition is false, j is incremented while I stands at the same position. Now we'll check, is 0 lesser than 1? The condition is true, so if the condition is true, the first step will be incrementing I, second step will be swapping I and j elements. That means 2 and 0 will be swapped, 0 will go here, 2 will be placed here. The next step is we have to increment j. J is now incremented. Now the next step is, as we have reached to the end of the array, what happens is again we have to increment I and we have to swap the elements at I and j, that is 2 and 1 will be swapped. 1 will go here, 2 will go here. Now as you can see, 1 was a pivot element and 1 has obtained its right position. All the elements towards its left hand side are lesser than 1. Okay, all the elements towards its right hand side are greater than 1. So this is how we have obtained it. Now if we again call quicksort algorithm, okay, quicksort function, okay, with 0, what happens, it since it is only one element, it returns 0 itself. Again if we call quicksort with 2, as passing the array with only one element, that is 2, 2 will be returned as it is. So the ultimate array which we obtained from this particular function is 0, 1 and 2. 0, 1 and 2. So 0, 1 and 2 will be returned to this particular function. Now once the 0, 1, 2 has been returned to this particular function, we can write it down 0, 1, 2. Now 3 is already sorted, this array is sorted. Now we'll again call quicksort with element 6. Okay, since it is having only one element, it will return it back. So once again 6 is returned as it is. So as you can see, this entire array is sorted. Now this array is returned back to the its the function which has called it. So what happens here is we'll write it down, that is 0, 1, 2, 3 and 6. Okay, this is a sorted array. Element 7 is already in its right position. Again, recursively we'll call quick sort with element 8, okay, which will return 8. So this entire function will return a value or will return an array which is this, that is 0, 1, 2, 3, 6, 7 and 8. As you can see, my friends, this was the original array which we had passed, and this is the array which we have obtained after quicksort algorithm has finished its entire task. So as you can see, the entire array has been sorted. So this is basically how quicksort works. Now let us write down this entire algorithm into C code. So first of all, what we have to do is we have to declare a function which is quicksort, which will take in arguments, which is the array itself, and it has to start with the start point and the end point. Okay, so in this quicksort algorithm, first we have to check if the starting point which is being sent as an argument, if it is less than the end the end point. We'll check this in order to compare if the array which is being sent, if it is a single element array or a multi-element array, or array which has more than one number of elements. So if start is lesser than end, now once start is lesser than end, what we have to do is first we have to find the pivot elements position. In order to find the partition point from where we have to partition the array into left and the right part, what I'll do is I'll declare an array int index of partition. So I have to call another function which will partition the array. So I have to pass on the same array start point and the end point. Now when I call this array, that is partition, which will take the array itself as an argument, the start point and the end point. Now again I have to declare a pivot element. Remember, in our examples we have used the last element of an array itself as a pivot element. So pivot is equals to array of end. Now I hope you also remember that the I variable which we had used, right, in order to index it, it was one step behind the start of the array. So I is equals to start minus 1. Now we have to use a for loop in order to traverse the array and compare it. So I'll be using a for loop where j will be equal to the start position until j is lesser than the end position. Until then j must increment. Now remember, if the element at array of j is lesser than the pivot element, what we have to do, we have to first increment I. Okay, next we have to swap. Okay, how are we going to swap this? We'll use a temporary variable. I'll use a temporary variable. Okay, now the temporary variable will store the value which is in array of I. Okay, then the value which is in array of I will be given the value which is in array of j, right? We're using a temporary variable. Then again the value in a of j will get the value which is in temp variable. Once we are done with this, remember we had a j plus plus here, else we don't have to have that, as j is incremented here itself. Once we are done with this, we have to again at the end we have to increment I. Remember, in the end, once j becomes to j is equal to the pivot element, we have to increment I, and again we have to swap the ith position and the jth position. In order to do that, again I'll be using a temporary variable which is equal to a of I. Okay, then the value in a of I will be getting the value which is in array of end position. Okay, end position is nothing but the pivot element, and again the value at a of end, the previous pivot position, will get the value which is in temp. So once this is done, we will have to return the I position, because I must be returned back to the partition point where the the array has to be partitioned from, where the array has to be partitioned into two parts. One is the left hand side and the right hand side. Okay, now once we are done with this, again we have to keep on calling quicksort recursively. Now here there is a catch. I'll be passing the same variable from the start. Remember, if this is my pivot element, okay, if I'm passing this particular array, I have to pass it from the start and until it is p minus 1, this position. So start minus the the partition position minus 1. And again, in order to sort the right hand side sub array, quick sort array, then now I have to pass an array which falls after the pivot element, that is p plus 1 until end. So that is index of, the index of partition plus 1 until end. So this is my difference how the entire algorithm works. So we will first call the quicksort function, which will check if the start position is lesser than the end position. If the condition is true, we'll check the position of the partition element. Once we get the position of the partition element, we'll call the quicksort a function recursively until we obtain a fully sorted array. So this is how quicksort algorithm works. I hope I have explained this to you in a very easy and simple manner. If you liked this video, then consider hitting the like button, and if you think subscribing to this channel is worth, then also consider subscribing. That's all for this particular video. I hope you liked it. With that said, this was Amir Salam signing off. See you in another one. Bye bye.